Hello friends, welcome. Today we're going to talk about CPCTC, and you did learn CPCTC before. It stands for corresponding parts of congruent triangles are congruent. So if I had two triangles, triangle ABC congruent to triangle DEF, the corresponding parts of these congruent triangles that would be congruent are the angles and sides that are congruent. So first you would need to say these triangles are congruent. And after you say they're congruent, I know that angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And the other sets of corresponding parts are the sides. Segment AB to segment DE. Segment BC to EF, and AC to DF. Now, in order to get any of these parts equal, you first have to say the triangles are equal. So these 6 things are your corresponding parts. And let's look. If you look at this first proof, you'll see you're proving parts congruent, angle C. So first you're going to have to prove the triangles congruent, then you're going to add on, after you get the triangles congruent, angles or sides congruent by CPCTC, which would go here. The bottom one, the same thing. You want these sides congruent. Therefore, step 5 is going to have to be triangle blah, 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 congruent triangle blah, 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 and your last step would be the CPCTC. So we use CPCTC to prove parts are congruent. And what are those parts? We just talked about it. The angles and the sides. But first, you must prove the triangles are congruent. And that would be your congruence statement. Okay? So let's see if we can do that proof. The first one, the given, segment AB, congruent to segment AD, given. I marked my picture, I write it in. Given, my second piece, BC, is equal to DC. I mark my picture, I write it in. Given. Now the object is to get the two triangles congruent. So I have exhausted my given. Look on your index card at what you add. You add a shared side or vertical angles. This side AC is in this top triangle and this bottom triangle. Therefore, it's equal to itself. It's a shared side. So AC is congruent to AC by reflexive. Now I look, do I have enough to say the triangles are congruent? I believe I do. I look at the top triangle, there are 3 sides. I look at the bottom triangle, there are 3 sides. So I can say my triangles are congruent by side, side, side. Now you have to write your triangle congruence statement. Match up the letters. I'll pick the top triangle, triangle ABC. Congruent to, well, they just fold on top of each other. So if I said ABC, I would say triangle ADC by SSS. Now, you want to prove angle BCA. BCA is this angle right in here at C. And this angle, DCA, are congruent. They are in my congruence statement, angle C, and they are congruent. I can end my proof with angle BCA congruent to angle DCA because they are corresponding parts of step 4's congruent triangles, and they are congruent to each other. So if you noticed, what did I do first? I proved that the triangles equal, and then I picked angle C's out of there to prove the corresponding parts. Let's do the second proof. You have parallel lines and angles congruent. PS is parallel to QR. So PS, this one's parallel to this one. and angle QPS is congruent to angle SRQ. So the first one is at angle P. I'll show you how I do it. P's the middle. Oh, well, it's just at angle P. Never mind. And at angle R. That was easy. Let's write it. Angle QPS congruent to SRQ. This is given. This is given. All right. Now, they give you the parallel for a reason because you need to add something from it. So I'll highlight it and I'll highlight my transversal. These lines being parallel will give me this little angle in here and this little angle in here congruent because they are alternate interior angles and they are congruent. So the lines being parallel will give me step 3. How do I name this angle in the top triangle? Well, it's angle S, but I need to name 3 letters. So this is how I do it. I say it's angle S up top. What are the 2 letters that it goes towards? It goes towards P and Q. So P will go on one side of S and Q will go on the other. The other one is at angle Q, and I look at that triangle and I see it goes towards R and S. So they're going to be on either side of Q, R and S. So I have gotten from the parallel lines, your alternate interiors, these are congruent. What else? I want to get the triangles congruent. I notice they have a shared side in the middle, QS. It's in the top triangle and bottom triangle. So I can say it's equal to itself by reflexive. Now look at the triangles. Are they congruent? I have an angle, and a side not included. So it's not between them, it's opposite them. And an angle, and a side not opposite them. So they are congruent by AAS. Naming your triangle is important. I will say triangle PAS. Congruent, so I started at P, went to S. No, PSQ. Sorry about that. The A's got me confused. And I'll start at R and go this way. RQS. By AAS. You want PQ equal to RS. Does PQ match up with RS? It does. PQ congruent to RS because these are the corresponding parts of the congruent triangles that are congruent. CPCTC comes after triangles congruent.